So the next video is how to solve power problems. So just a reminder about some of the values that we've used before and that we're going to use again. We have voltage. Voltage is symbolized by V, and the unit for voltage is volts, which we also use a V for. We also have current, symbolized by an I, measured in amps, which we use an A for. Some new values that we're going to be using for power calculations. We have power, which is symbolized by a P. Now power is measured in watts. And the symbol for a watt is a W, capital W. We will also deal with energy, which is symbolized by an E, a capital E, which is measured in joules. And that is a capital J. Lastly, we will deal with time. Now time is symbolized by a lowercase t. It's important that it's lowercase. We measure time always in seconds, which is of course a lowercase s. So what that means is that when we're dealing with time, we don't want minutes or hours, we always need to convert it to seconds. We also have some new formulas for power. There's two that we might be using. The first one deals with power, current, and voltage and the relationship between those two. So P equals IV is the formula. If you're placing that in a triangle to help you, P is going to go on the top, and I and V would be on the bottom. All right, the other formula that we also have is P equals E divided by T. All right, so if we're placing that in a triangle, we're going to put energy on the top and P and T on the bottom. All right, so we are going to solve our first power problem. Page 12 I've just put up here because that is the page in your notes that gives you the instructions on how to solve a power problem. Now the step-by-step is very similar to Ohm's law, but follow along in your notes if you can. So first off, the problem that we have is a current of 10 amps passes through a device that is connected to a 120 volt outlet. What is the power of the device? So first up, always in a physics problem, we're going to list our knowns and our unknowns. So first off, I have a current of 10 amps, so I equals 10 amps. It's connected to a 120 volt outlet. V equals 120 volts. And they're asking for the power. Power is my unknown. Okay. Now that I have my unknown, I need to figure out what formula I'm going to use. If I look up to the top right corner, we're obviously going to use the P equals IV formula to solve this one because we have power, current, and voltage. So I need to write down my formula always. P equals IV, and then I substitute my values. So that's 10 amps times 120 volts. Once I substitute my values, I can calculate. So 10 times 120 is going to be 1200, and I have to include the unit, which for power is watts, so capital W. Okay, let's try another problem now. What is the power of a device that uses 45 joules of energy over a 15-second period? So still a power problem, but this problem is going to have us calculating power using energy and time instead of current and voltage. So I'll just go through this. So first thing always is to list our knowns and our unknowns, of course. So we have 45 J of energy, and now J is a joule, and energy is symbolized by E. So E equals 45 J. Okay, it uses that energy over a 15-second period. So lowercase t is our time, and t equals 15 seconds. They're asking for power. So power is question mark. So looking up at the formula in the corner, P equals E divided by T. Okay, we can now substitute our values. 45 joules divided by 15 seconds. And when we calculate that, we will find that the power is 3 watts. All right, we will do another problem, a harder problem this one. So the problem is a 50-watt device is on for 40 minutes. How much energy does it use? I'd suggest at this point in time that you try and solve this one on your own, and then come back and see my explanation of it. All right, so this one is very similar to the one we just did, but just a little bit, just one more step really. So first off, let's list what we know and what we don't know. So our first known is a 50-watt device. So 50 watts, that is power. All right, given us time, and they want us to figure out energy. Okay, so they've given us time, but they have given us time in minutes. So this is the extra step that we're going to need to do. In order to figure out time, we're going to need to times 40 by 60. So 40 times 60 equals 2,400 seconds. Okay, so now that we've done that first step, we need to just solve it like we normally would. So for E is what we're looking for, energy. If you look up to the top, look at that triangle. To solve for energy, we're going to need to multiply power and time. So E equals P times T. E equals 50 watts times 2,400 seconds. And that equals 120,000 joules. Now let's say that 120,000 joules is your answer, but you were asked to give the answer in kilojoules and not joules. So this is kind of bringing us back to where we need to be able to be comfortable to convert between kilo and milli and just the different units, okay? So for 120,000 joules, so if we needed to get that to kilojoules, so go from joules to kilojoules, we divide it by 1,000. So 120,000 divided by 1,000, that's going to equal 120 kilojoules, which is a little bit more manageable of a number, which is why we might want to represent it in that